Okay, in this lecture we're going to look at circular motion. So look at these objects moving in a circle. A car traveling around a circular ramp on the highway, a ball tied to a string being swung around in a circle, the moon as it travels around the earth, and a child riding rapidly on a playground merry-go-round. For each of these examples, answer the following, and you can do this in your head. Is the circular motion caused by a force? If so, in what direction is that force acting, and what is the source of the force acting on each object? Think about that for a couple seconds. So tangential speed, you guys probably have heard of a tangent line. Well, it's the speed in the direction of the tangent line. And in uniform circular motion, vt, so that's the tangential speed, has a constant value. Only the direction changes. So your speed is staying the same. Your direction changes, so that's why the velocity is changing. Remember, velocity is a vector. And so since the direction itself is changing, the velocity is changing. So how would the tangential speed of a horse near the center of a carousel compare to the one near the edge, and why? Well, farther away, aren't you moving a little faster because you're traveling in the same distance, but you got to go a little faster. Think about those of you that are marching band when you're walking around a corner in a parade. The outside people have to march a little faster to keep up with the inside. Same idea there. Centripetal acceleration we represent by AC. It's the acceleration. Well, since we have a change in velocity because we had the change in direction, we do have an acceleration. It's not necessarily a change in the speed, but it's looking at the change in the direction. And that acceleration is towards the center of the circular motion, towards the center of a circle. Centripetal means center seeking, and so the magnitude depends on the speed. Here's our equation for centripetal acceleration. AC, which is centripetal acceleration, is equal to the tangential speed squared over r, the radius of the circular path. So tangential acceleration occurs if the speed increases and it's directed tangent to the circle. So a car traveling in a circle, centripetal acceleration maintains the car's circular motion and it's towards the center of the circle. Tangential acceleration is an increase or decrease in the speed of the car. So if the car is speeding up around a corner, or like the speedometer would actually change, or if it's slowing down around the corner, that would be tangential acceleration. Centripetal acceleration, whenever you're going in a circle, there's always centripetal acceleration towards the circle. It's keeping that object going around in a circle. Otherwise, an object, if it's not being held in the circular path, it would fly off in a tangent line. Let's see what this is. So here you can see the direction of the velocity in this corner right here. The direction is changing, the magnitude is not changing at all. So the acceleration is just the centripetal acceleration towards the center. So centripetal force, for there to be an acceleration, there has to be some sort of net force. And we use the same equation, F equals ma. We're going to say centripetal force is equal to mass times centripetal acceleration. And since AC is equal to V, the tangential speed squared over R, we can plug that in so we can have FC is equal to mv squared over R. So the centripetal force maintains the motion in a circle, It can be produced in such different ways, like gravity can be the force that causes centripetal acceleration, like as the Earth goes around the sun. A string, if you're swinging a ball around on a string, the string is giving that force towards the center. Friction, a car going around a circle or around a corner, the friction of the tires in the ground is what's giving the force to come around in a circular motion. And in which way will an object move if the centripetal force is removed? Well, if it's removed, let's say this is a string, a ball on a string, and that string breaks, it's going to go flying off at the tangent line, in a tangent line, going off in a straight line. So imagine yourself as a passenger in a car turning quickly to the left and assume you are free to move without the constraints of the seatbelt. What does it feel like to you during the turn? Most of you will say it feels like there's a force pulling you to the right. How would you describe the forces acting on you during this turn? Is there really a force pushing you to the right? No, there is not. It is actually, that's what's called centrifugal force. Actually, what's happening is, since your body is not attached to the car, your body is trying to go off at a tangential line, but the car is moving in a circle. So as the car comes around the circle, your body is going in a line and it hits the side of the car. Your inertia is causing you to continue in a straight line. So let's try a couple problems together, and then you can work on your other assignments. A 35-kilogram child travels in a circular path with a radius of 2.5 meters as she spins around on a playground merry-go-round. She makes one complete revolution every 2.25 seconds. What is her speed or tangential velocity? Okay, so what is her, it says hint, find the circumference to get the distance traveled. What's the total distance she travels? What's the equation for the circumference of the circle? Isn't it 2 pi r? So that would be 2 pi, and then the radius is 2.5. So when we calculate that out, we get 15.7. That's what I get. And then it'll be over time. So what we get is 6.98 meters per second. So that would be our velocity. Next question asks for his centripetal acceleration. So her AC is equal to V squared over R. So V squared, we had 6.98 squared over R is 2.5. And I get 2.79. And centripetal force, we can just use the FC equals MAC. So we'd have the mass, she's 35 kilograms, times 2.79. .7 newtons. Okay, let's see if we got those right. Oh, you know what I did? I think let's go back to this acceleration equation because I didn't do that right. I forgot to square it. 6.98 squared divided by 2.5. Yep, I get 19.49, or 19.5, I guess. So let's go back. This is actually 19.5, which means taking that times 35 to get our force, I do get 682. So now that was the answers, right? Yep, 19.5. I forgot to square that speed. So squaring is very important. So now what do you think? Consider the objects in the circle again. The car traveling around a circular ramp, the ball tied to a string, the moon, and a child riding on the merry-go-round. So is the circular motion caused by a force? If so, what direction is that force, and what's the source? So yes, there is a force. It's the centripetal force. That force is always towards the center of the circle. And so for the car, the source would be friction. The ball would be the string. The moon going around Earth would be the gravity. And the child riding on the playground, I would say would be friction again. It's holding that child on the merry-go-round.